bigger in size than any wheel before them, 20 inch in the front and 21 in the rear. They're still the lightest by far we've ever made. And the engine is very much recognizable as a Koenigsegg engine. It's a 5-liter engine, but with a lot of new technology. It has a 180-degree crankshaft, which is 4 kilos lighter than the 90-degree crankshaft we've used up until now, which is already very light. So there's a weight saving there. The 180-degree crankshaft also allows for even better pulsations to the turbos. So we get around 40 horsepower of free energy that, we kind of use the energy inside the engine even better. We have done a lot to comply with the latest emission regulations. This car has to basically survive until 2026 emission regulations in California and other places. So we have a secondary air system to heat up the catalytic converters, and we have a turbulence creating system for the intake of the engine to make sure we can combust even cleaner on cold start. And we also have electrically heated cats, so we can get them up and running really quickly. We have, for the first time in the world in any production engine, we have in-cylinder pressure sensors for each cylinder. So we can, with a closed loop algorithm, tune each cylinder individually to run optimally from one stroke to another. And that's a world's first for a production engine. The turbo system is new on the car. It's a bigger turbo than we've had before. This has the benefit of reducing the back pressure, which gives more power. It has the benefit of being able to supply more airflow at high boost, but it has the negative effect of reacting slower in transitions because you have more inertia to overcome in the impeller and the turbine. So we came up with a system where we have a 20-liter carbon fiber tank on board, which is pressurized by a small electrical compressor. And then we strategically inject air in the turbo system to help spool up the turbos as quickly as possible. We're talking about less than a second or so bursts in transitions, but it makes the turbo feel like a really small turbo. Also, it helps a big turbine to create boost at lower airflows than it normally can. And this engine package, even though it complies with the next level of emission regulations worldwide, it still brings up the power level from previous generations. So we're talking about 1280 horsepower on 95 octane fuel European or 91 US, which is unheard of from a 5-liter engine. And then if you choose the E85 upgrade option, which will be available for some markets, then you're talking 1600 horsepower. So I would say Koenigsegg is very technology agnostic. I mean, we have a very different set of technologies in the Jesko compared to the Regera. And it's basically allowing our development teams to work on what is best for this particular type of car, what makes most sense. And I mean, the world is going very much electrified as we speak, and we're very open to that. I mean, with the Regera we have the world's first series-produced homologated 800-volt propulsion system. That's super advanced, and we have the capability of making a fully electric car with no combustion engine at all, but that's not what we're choosing to do right now. We're choosing to optimize for different purposes with whatever technology that makes most sense. And in this case, it's a 9-speed transmission, and in the case of the Regera, it's very much of an electrified propulsion system. What you also can see in this area is the negative space bodywork design, where we're really letting the aero work its way through the bodywork in different areas. So here, this opening to the front wheel, where you can see the very long front wishbone, adds a lot of downforce to the car. As I mentioned, it's over 880 kilos at 250 kilometers per hour. And this kind of openness works its way throughout the car, very much open in the rear, to let the air flow freely and openly wherever it wants. So I'm at the front of the Jesko here, and what is very evident is that it has a really big front splitter. So we really need to create as much downforce in the front as we can, as we have really big diffuser in the rear, an enormous active wing with a braking air feature as well. And if we compare this to our highest downforce car so far, which is the Koenigsegg 1-to-1, that had 600 kilo at 250 kilometers per hour. This one has 880 kilos downforce at 250 kilometers per hour. And if you go up to 270, which is close to 250 of course, it's 1,000 kilo, a ton of downforce at 270 kilometers per hour. So we really have massive amounts, and we have to control and level this out front and rear and make sure our suspension still works with this kind of downforce. So we have our active underflaps left and right under the front splitter. We have active ride height control, and we have an active rear wing. But if you come around here and look at the front, we have a new damper element here that we haven't seen in any other Koenigsegg. It's the front triplex. We've had rear triplex since the beginning of the Regera R program, and that really took the handling to a new level. But we've taken that again to the next level with this car by also implementing it in the front and the rear, and we're also having these progressive springs, which means that when we go down to track mode, we increase the spring stiffness with over